Well, welcome to our discussion of limits. So this is our first calculus topic, and we're just going to start with a brief mental exercise here before we get into any of the mathematics of it. And we're actually going to go back to ancient Greece and a Greek philosopher named Zeno, who was a bit of a smart aleck. He liked being very contrary and basically just calling out people he thought were foolish. And what we want to examine here mentally and just kind of picture, or you can even get up and do this, is what's called Zenos Paradox. And it's this idea that I've seen it presented several ways and attributed to Zeno. But the basic idea is if you stand some distance away from the wall, and if I were to say, here's the wall, here's where we are, here's a person, you're some distance away. And Zeno said, well, move halfway to the wall. So now you're here. And then Zeno said, well, move halfway again. And so now we're here. So we moved here, then here. And then Zeno said, no, move halfway again. So now we're here. And then halfway again, and halfway again, and halfway again. If you keep doing this, in other words, if the distance between you and the wall keeps getting cut in half, do you ever actually reach the wall? And this is a paradox because there are actually two different ways of thinking about this. We have the mathematical way, which says, well, if the distance is always cut in half, I know I've reached the wall when the distance is 0. So if the distance is always being cut in half, like 1 foot, half foot, quarter foot, eighth of a foot, 1/16th, 1/32nd, 1/64th, and so on, the distance never actually reaches 0. So mathematically, if the distance between you and the wall is always getting cut in half, you never run into the wall. But then reality kicks in, and as the GIF here does a lovely job demonstrating, you run into the wall. And so this is the basic foundation of what is considered a limit in math. And I'm not going to go through the exact formal definition of a limit because even with my degree in calculus, it's a hard definition. But the basic idea of a limit is that we have two variables we deal with. We have an independent variable that we control and a dependent variable, which we usually call a function, which depends on the independent variable. So as an independent variable approaches a given value, in other words, as the person is walking towards the wall, what does the dependent variable approach? Okay, so our independent is you walking towards the wall. The dependent is how far away from the wall are you? So as you approach the wall, what happens to the distance? The basic idea of that doesn't sound that hard, but these are actually really, really challenging because what we have to break ourselves of the habit of is we don't care what happens at the wall. It's only as we get infinitely close. So that's going to take some practice and some discussion, and it's probably going to be something that we as a class are going to have to talk about. So it's not what happens when we reach the wall, but what happens when we get infinitely close to the wall. So close that it actually doesn't matter whether we consider it running into the wall or not. Now, we do have some notation that goes with this, because when we are looking at a graph, if this, say, here's my function, and I'm looking to see what happens as I approach here. Well, I can approach that value of 4 from the right, and this would be called a right-hand limit. So when I see this notation, I would say the limit as x approaches a, and this little superscript plus means from the right, of f of x. So the limit as x approaches a from the right of f of x. Thank goodness we can use this notation to write it, but when we say it, it's said the long way here. So here I would be saying the limit as x approaches 4 from the right of this function f of x, whatever it would happen to be. If I wanted to approach from the other side, this would be a left-hand limit. So this would be the limit as t approaches b from the left of g of t. So again, this is the long way of saying it. This is how we write it. It's the limit as t approaches b from the left, because that's a negative superscript, of g of t. Strictly speaking, those are the only two limits. But a lot of times we care about what happens as we approach a value from both sides. So if I wanted to approach 4 from the left and the right, we can do a shorthand of what's called a two-sided limit. So the limit as s approaches 7 of k of s. With no little plus or minus superscript, we're implying we actually want to approach from both sides. The only way we can do that is if the limit from the right and the limit from the left are exactly the same. If the limits were different, the limits wouldn't actually exist. And that I will save for the next video.